Now, so far we have looked at the molar mass of individual atoms, such as sulfur in the last example, or fluorine. But what about the molar masses of compounds? Since when we step in the lab, usually we are working with compounds, we want to know the molar masses of compounds. Compounds have a formula, as we learned in the previous chapter. There are ionic compounds and covalent compounds, and they are made by combination of various elements. For example, the ionic compound sodium chloride, which is table salt, is made up by combining one atom of sodium and one atom of chlorine to give us the formula NaCl, while the covalent compound water is made up of H2O, two hydrogens and one oxygen. When it comes to ionic compounds, we don't call them, specifically we call the formula a formula unit. So when I say NaCl, it's NaCl a formula unit, because we know that it's a huge network of many NAs and many Cl's, but the smallest whole number ratio is 1N to 1 Cl. That's why it's called a formula unit. Ionic compounds have formula units, while covalent compounds have chemical formulas. H2O is a chemical formula, NaCl is a formula unit. Okay, here are some more examples of formulas. These are not compounds. The first one is not compound. It's a molecule. It's a diatomic hydrogen molecule where you have two hydrogens. Here you have a chemical formula of water. You have the formula unit for NaCl. And see, this is calcium hydroxide, another formula unit where you have one calcium and two hydroxides, which is made up of one oxygen, one hydrogen each. So what about the molar masses of this, the chemical formulas and formula units? How do we find that out? Well, it's also not very difficult. What you do is look at the total number of each kind of atom, and on the periodic table find out the mass of each atom, okay, the atomic mass or the molar mass, multiplied by the total number of each atoms and add all of them up. For example, ammonium sulfate made up of two ammoniums and one sulfate, but exactly how many nitrogens? Two nitrogens. Okay, this 2 here applies to this nitrogen. 4 times 2, 8 hydrogens, 1 sulfur and 4 oxygen. Here is another formula. This is called a hydrate, by the way. Many compounds many salts are compounds which absorb water from air. They are used as drying agents or desiccants, and they basically lower the moisture in the air, the amount of humidity in the air if they are dry. 1 unit of copper sulfate absorbs 5 units of, or 5 molecules of water. Okay. The name of this compound, by the way, is copper sulfate pentahydrate. 5 for penta, the Greek suffix. This is how it looks when it's hydrated with 5 molecules of water, and this is how it would look if you dry it up by heating it and releasing all the water. So what's the formula mass of water? Okay. Or the molar mass of 1 mole of water? Well, since 1 mole of water contains 2 hydrogens, one formula unit of water, H2O, contains 2 hydrogen and 1 oxygen. You have each hydrogen at a mass of 1.008 amu times 2, plus 1 oxygen has a mass of 16.00. When you add that all up, 1 molecule of water has a mass of 18.02 amu. Okay, listen to what I just said. 1 molecule of water has a mass of 18.02 amu. What about the mass of 1 mole of water? What do you think the answer will be? The answer will be similar to how we found the answer to previous conversions between AMU and grams. Okay. whatever using the fact that one atom, whatever its mass is given in EMUs, but if you want to know the mass of 1 mole of that atom, it's the same number but in grams. Similarly, if one molecule of water has a mass of 18.02 AMU, the mass of 1 mole of this molecule will have the same number but with the unit of grams. So 1 mole of water, known as the molar mass of water, has a mass of 18.02 grams. That's your covalent compound, water. What if you had an ionic formula unit, ionic compound like ammonium phosphate? As we said, it's a formula unit because it's made up of a large network, but the simplest whole number ratio in the case of ammonium phosphate is 3 ammoniums for 1 phosphate. Well, you got 3 nitrogens, each one has a mass of 14.01 AMU. You got 12 hydrogens, 4 times 3, 12 hydrogens, that's 12 times 1.008 AMU. You got 1 phosphorus whose mass on the periodic table is 30.97 AMU. You got 4 oxygen, each one has a mass of 16.00 AMU. You multiply each one by their exact number of atoms found in the formula unit, and then you add each of the numbers and do the math with the right suffix, and you get the molar mass of this compound, or the formula mass, as 449.10 grams per mole. So this is how we find the mass of a compound, whether it's ionic compound, the molar mass of a compound, whether it's an ionic compound or a covalent compound.